today I'm going to have you look at some problems that involve either an angle of elevation or an angle of depression. Either one, if you look at the definitions, an angle of elevation or depression is formed by the horizontal and the line of sight. So you have to think about this two ways. Kind of picture two laser beams coming out of your eyes. One goes directly out. The other laser beam follows the path that you're looking on. This angle right here is an angle of elevation. An angle of depression is going to be found here. Now, the most common mistake I see on the angle of depression is people think that this right here is the angle of depression. This is not the angle. It has to be between a horizontal and your line of sight. This would be if you're looking down at something. So if we look at an example, example 3 says, Cindy knows that when she stands 115 feet from the base of a flagpole, the angle of elevation to the top of the flagpole is 25.4 degrees. If her eyes are 5.6 feet above the ground, find the height of the flagpole. I find on problems like this, it's much easier if you draw a picture. So we know we have a flagpole. There are to be no comments on my artistic ability. Cindy is standing 115 feet away. This is as good as it gets, sorry. And it says from where she's standing, her eyes are 5.6 feet above the ground. And the angle of elevation, here would be the horizontal coming out of her eyes, and she would be looking to the top of the flagpole, and that angle of elevation is 25.4 degrees. Okay. Our ultimate goal is to find the height of the flagpole. Okay, but you can kind of tell we're going to have to do this in pieces. The right triangle that we're going to be working with is right here. We also have this additional 5.6 feet that we will need to add on. So it's almost like we're going to break this into two pieces. We're going to find this height and then include the 5.6 feet. Okay. Well, looking at what we're trying to find that side of our right triangle. Well, we need to have another side. But again, you can kind of see this rectangle shape right here. If it's 115 feet away here, this will also be 115 feet. Okay. And if you look at the sides you have in reference to this angle, we have the adjacent side and we're looking for the opposite side. The trig function that uses opposite and adjacent is tangent. So we're going to set this up as a tangent problem. And just like yesterday, we need to plug in what we know and solve for what we don't know. Oh, I should have made that a theta, but whatever. All right, so it'll be the tangent of 25.4 degrees equals the opposite side, which is x, over the adjacent side, which is 115. And just like yesterday, to undo this division, we need to multiply both sides by 115. And on your calculator, when you do 115 times the tangent of 25.4, you get a height, or a value for x, of about 54.6. That is this portion, but don't forget we also have the additional 5.6 feet to the ground, and so the overall height of the flagpole is going to be 60.2 feet. If you look at the next example, here in his example using the angle of depression, it says a monkey is sitting in a palm tree. He is sitting 23 feet off the ground. He spots a coconut on the ground that is 37.5 feet away from the base of the tree. He says find the angle of depression. So what it's asking us to find, okay, it's not this angle. The angle of depression is going to be this angle. Now, we have to kind of think about how we're going to do this. That angle is not part of our triangle, but if you remember back to chapter 1, when we talked about those special angles formed by parallel lines, this angle and this angle are alternate interior angles. They should be the same measure. So, working with my right triangle, if I can calculate the value of this angle, that will be the same as my angle of depression because they are alternate interior angles. Again, if you notice, the hypotenuse was not given here. We have an opposite side and an adjacent side, so this is going to be a tangent problem. The tangent of my angle is going to equal the opposite side over the adjacent side. This is similar to the second example we did in class yesterday. We're going to need to divide this fraction. And so 23 divided by 37.5 is going to give us a decimal value of about 0.6133. And remember, if the tangent of a certain angle has that value, to get back to the angle, that's when you're going to want to use your inverse tangent function, okay? So we're going to hit second tangent of 0.6133, and that tells me that my angle that I'm looking for is 31.5 degrees.